Hello ladies and gentlemen, I need to go over some very important notes with you for this unit. We haven't done much of that, but here it is. Chemical bonding. Chemical bonding. A lot of these you are already familiar with. A lot of these, there might be some new points here that I need to make. So take notes along the way. Set up a page in your notebook, title it Chemical Bonding. Chemical bond. A chemical bond is a mutual electrical attraction between the nucleus and valence electron of different atoms. So it is to make atoms more stable. All atoms want their outer shell to be full. So remember, basically it's the nucleus in the middle that's doing all the attraction of electrons. Okay, so whenever it's got 7 electrons on the outer shell like this, like a chlorine or a bromine ion here, or not ion, atom here, it's gonna attract another, let's say sodium. Sodium's only got 1, so it's gonna have that attraction toward the nucleus attracting another electron from somebody else. Okay, so the nucleus and valence electron of another atom, there's attraction between them. That's what creates a bond. And so once it's attracted, they both should be fairly happy because the outer shell is full, and so there is an equal. That makes it more stable. And then an atom with an unfilled outer shell will likely to bond with another atom. Noble gases have their outer shells full, so they will unlikely bond with anybody else. Remember, we know helium, neon, argon, krypton, xenon, they all have 8 on the outer shell. They're happy, so they don't need to bond with anybody. Characteristics of bonds. So here I'll talk to you about the difference between covalent and ionic bonds. You have some of these notes already, but write down the things that you don't have yet, or just write down everything so that you can review again. Covalent, share electrons. The key word here is share. Between 2 or more nonmetals, they form this thing called molecules. Ionic bonds. So let's look at circle some keywords there. Shared pair, 2 or more nonmetals, and then they form molecules. Okay, they form molecules. All right. The ionic bonds, on the other hand, is between a metal and a nonmetal. One will give up electrons, the other will accept electrons, and ions are attracted because they are oppositely charged, and this attraction is called an electrostatic attraction. Electrostatic, it's a weak electrical charge that allows them to be attracted to each other, and that attraction is between the cation, which is positive, and the anion, which is negative. Okay, and the cation is always the metal, and the anion is always the non-metal. All right, so moving just along. And they form salt and crystal lattice structure. Okay, salt is like NaCl, KCl, CaBr2. So things like that, those are salts. Okay, covalent bonds, there are 2 types. You have polar and you have non-polar. Polar, there is an unequal attraction of electrons. That means it's unbalanced. Okay, you have one side that has more electrons. So like this molecule at the bottom right here, this water molecule. Oxygen, if we drew the Lewis structure, it has these 2 lone pairs on top. It's going to pull electrons that way. With this sign, the symbol kind of tells you that. And so hydrogen side, it becomes slightly positive. Oxygen slides kind of negative. So therefore, you have 2 poles. We have what we call a dipole. Okay, this line right here shows you that it's got a dipole. One end is slightly negative, one end is slightly positive, and it doesn't balance out, so therefore it's polar. Okay. On the other hand, if you look on nonpolar is electrons are shared equally between the bonded atoms. They are shared equally, meaning here. So if you look at these, the carbon and the chlorine, all right. So all of them, each bond is polar. Carbon and chlorine, they're not balanced. But because there's 4 of them, they cancel each other out. So the 4 dipoles, they cancel out. Dipoles cancel out to make it balanced. And so therefore it's nonpolar. Okay? So polar is unbalanced. Nonpolar is balanced. Alright. Here's a few more. Here's a few more examples. HCl, it's clearly HCl at the top left-hand corner here. It clearly goes toward the chlorine, so therefore it's polar. This NH3 over here is rather interesting because it goes toward the nitrogen. It's more electronegative. But if you remember drawing the dots, there's a lone pair up on top. Okay, that's what pushes these things downward, and therefore you have this pyramid shape, and the electrons will be unbalanced. That's why it makes it polar, unbalanced. Okay, polar is unbalanced. And then the last bond that we need to talk about is called metallic bond. A metallic bond is between metal ions, and it's interesting because it's not like ionic or covalent. Ionic transfer, covalent shares. Metallic, all the valence electrons, they just float around to form a sea of electrons. They float around, they move, they're very mobile, they're always moving. So you have the cation stay still. See all the drawings down here? The cation down here, let me change color real quick here. Colors down here, they stay still. All the positive charges stay still. And all the orange dots here, they move around. They move around in this cloud, in the sea of electrons. So because of their movement, it allows them to conduct electricity right here, down here. So some properties of metallic bonding. It's a very strong attraction between metal atoms. And so they're very tightly packed. The ions, the positive parts, very tightly packed. Then the electrons will just flow freely though, allowing it to conduct electricity. It has high density because it's very packed. And some key points here: high melting point. Have you ever melted metals? You realize that it takes so much heat to melt a metal, so the temperature has to be really high to melt metals. Okay, lustrous means it is shiny. Okay, it reflects a lot of light because of the way the electrons behave. Ductile, potato, I don't know how that works. You can make it into fine wires, like the wires that conduct electricity through your earphones, through your phones, things like that. And malleable, you can shape and you can bend and you can flatten them. Okay, shape, flatten them. All right, we can flatten into sheets like aluminum foil. We can shape them to other things, other metallic structures. All right, so very, very important point here. Metallic bond, sea of electrons. Electrons are mobile. They're always moving. They don't belong to any individual atom. They belong to everybody, basically. It moves around the whole thing. So 8 is not the magical numbers for these metallic bonds. Okay. All right, moving along. And we talked about the VSEPR theory, which is the valence shell electron pair repulsion. It states that repulsion between the valence electrons, the electrons want to be as far apart as possible, and it explains the shape. So if we have lone pairs, like nitrogen, if we have a lone pair up there, it's going to push these down, so then we have those hydrogens being pushed downward here. And so they want to be as far away from each other as possible. It's just like oxygen with 2 hydrogens. And so they want to be as far from each other as possible. Alright? And that's what gives them the shape. And the different shapes here. Hold up. Different shapes here that makes a straight line. It is linear. So it makes a straight line here. Like the first one. Makes a straight line. Look at that. Makes a straight line. It's linear. Makes the one on the right makes sort of a V shape. It's bent or angular. Angular. Yeah. And then this one here makes a perfect triangle. Trigonal. Planar. Makes a triangle because the middle one does not have any lone pair. So the center atom, no lone pair. No lone pair. And they use BF3 because boron, if you know, it has 3 valence electrons. So they want to be as far away from each other as possible. It looks like that. And if I'm just put H's because it's easier. It's just one dot. I don't want to draw all the dots for fluorine. But there you go. You have this shape of a triangle there. There's no lone pair in the middle. As opposed to going to the right, all the way to the right, we have the pyramid here. Pyramidal. This is trigonal pyramidal. It's still triangle, but it's pyramidal because this nitrogen, as shown in this picture here, this nitrogen in the middle, it has a lone pair up on top right there. What it does is it pushes these guys downwards to make that pyramid looking thing. So if there is a lone pair, it's going to push things away. Okay? Push other electrons away, other regions of electrons away, giving it a different shape. So that's trigonal pyramid. And then we have the last one, tetrahedral. Anytime you have 4 things connected to one thing in the middle, that is called tetrahedral. Okay? As you get to college, you'll need to know the angles between them, and for our sake, you don't need to yet. So it's linear again, bent or angular, trigonal planar, trigonal pyramidal, and tetrahedral. That is so for the slides today. Good luck. I hope you guys enjoyed that. Very quick and smooth there. Learn all that, review all that.